Hi there, this is video 2.7b exact transformations. In this video, we're going to learn how to use exact points to do the dilation. Before, we were just concentrating on translations and reflections, and we were flipping or translating the graph over the x or y axis, and we were sliding the origin 0, 0 from left to right or up or down. So now we're going to find the exact value to find exactly how wide or how narrow our graph becomes or it changes. So our vocabulary is translation, reflection, dilation. You should know translation is a slide, right, left, or up and down. Reflection is a flip over the x-axis to the y-axis. And dilation is what we're going to really concentrate on, the enlargements or shrinkings or stretch or compressions, either vertically or horizontally. So let's first start with our general formula. So we've talked about this general formula, A, B, H, and K, and how important those are in transformations. So in this box, you need to write in X and Y. Okay, so this stands for the parent function, whatever it would be. For instance, if it was the absolute value of x, that would be the parent function. Okay, so there are going to be some coordinates x, so you can make a table, and it's you make up your own values for x, and then you plug them into here, and you say the absolute value of 0. What is y when the absolute value is of 0? You have 0. You put 1 in here, y is 1. You put negative 1, it's 1. 2 is 2, and negative 2 is 2 as well. Then in the box it says transformations. Okay, this is where it becomes really important. So let's start with the K. So we have A, K, B, and H. Okay, so let's write these things down. So what is A? A tells us if we have a dilation and or a reflection. If A is negative A, you have a reflection, vertical reflection over the x-axis. If the absolute value of A is greater than 1, you have a vertical stretch. If the absolute value of A is less than 1 and greater than 0, you're going to have a vertical compression by the value of A, not the absolute value, by a factor of A. So A is going to be times, so it's going to be A, Y, parentheses, because order of operation, plus K. What is K? Both of these are vertical transformations because they're outside the function, and K is going to tell us if we slide up or if we slide down. If K is positive, we're going to slide up, and if K is negative, we're going to slide down. And these will affect the Y coordinates because Y goes up vertically. Now let's look at B and H. So B is a horizontal dilation or reflection. So when you have negative B, you have a horizontal reflection over the y-axis. If the absolute value of 1 over B is greater than 1, you have a horizontal stretch. If the absolute value of 1 over B is between 1 and 0, then you have a horizontal compression. All right, so that's going to be the factor. It's 1 over B is what it's going to be times. That's the factor that is dilated. And negative would show reflection. Now, what is H? H tells us, do we slide to translation right or left? So if H is positive, it's going to go to the right. If H is negative, it's going to go to the left. These are translations and it's horizontal. Now remember, let's look at this example, x minus 2 squared and x plus 2 squared. Okay, these are both H, but what is H? Remember the formula is x minus H. So you're going to take this and say x minus positive 2. It's still all squared. So H is going to be, in this example, positive 2. All right, and then in this example, you would rewrite this to say x minus -2. In this example, h is going to be -2. So we're going to do 1 over b, not the absolute value, times x plus h. Because remember, we've already figured out what h is by changing it, so we don't rechange it here. So that goes in that box. And I just went through what they all meant. So let's look at what this means. So let's just take a basic one without dilation. So if I have, on example 2, we're using these same examples, but we're not doing what they asked. We're doing what I said. So first of all, identify the parent function. So the parent function is going to be f of x equal the absolute value of x. Now we're going to make a table, an xy table, of the parent function. So let's just 0, -1, 1, 2, -2. So if x is 0, y is 0. If x is -1, y is 1. If x is 1, y is 1. If x is 2, y is 2. If x is -2, y is 2. All right? So then we're going to come over here and we're going to do our translation. So let's identify what we have. So a is 1, b is 1, h is 0, and k is 2. Okay, so really the only transformations that are going on here are k, because if you have a and b are +1, there's no reflection and no dilation, and if h is 0, there's no slide. So the way we did this before, and since there's no dilation, it really doesn't make any change, but do you have the exact values? So it's going to go up 2, and I don't know if it's exactly right, but let's find exact values. So x does not change because times 1 is just x and plus 0 is just x. So we could theoretically say 1 times x plus 0, and we're going to get x. Here we have 1 times k plus 2, so we're going to say y plus 2. So our x's don't change, just our y. So let's put in these values for this equation right here. So 0 plus 2 is 2. 1 plus 2 is 3, and 3. 2 plus 2 is 4, and 4. So let's go plot these. So 0, 2, yes. And 1, 3. So 1, 3. So I did pretty good at eyeballing this. A little off here. -2 and 4. And then we connect the dots. So I did pretty good at making this graph. So on the test, you're going to have to give me at least 5 points. So you can use any points for x. I just go with the basics, find what y is, and this is the parent function. Then I use my formula here, and then all you do is you transform these. So let's do another one, because I didn't have dilation. So the next example's got to it. Let's do a basic one again. So it's y equals the absolute value of x plus 3. So again, we only have what? H. So h equals -3. So we're going to make our formula for x and y 0, 1, -1, 2, -2. We put this into, remember, this is the parent function. X is 0, 1, 1, 2, 2. Okay, so now we said this is going to be x minus 3, comma y, because there's no a or k. So I can rewrite all my y values from the parent function. Now you got to make sure, so you put 0 into here. So 0 minus 3 is -3. You make sure it goes next to 0. We'll put positive 1. 1 minus 3 is negative, put negative 1. 1, we get negative 2. We put negative 1, we get negative 4. We put 2 in here. 2 minus 3 is negative 1. We put negative 2 as negative 5. So now we can just go graph these, and we get 1, 2, 3, 0, 1, 2, 1, 4, 1, negative 1, 2, negative 5, 2, and we see what happened to our parent function. It just slid to the left 3. But we have the exact thickness of the graph. Let's do one with dilation, and then you can try the others, except for on your table, I want you to change those numbers to just simple numbers like 0, 1, negative 1, 2, and negative 2. And on the square root, I would just put perfect squares in there for x. So I'm changing 2b to say 2 times 1/3, bracket, x minus 1 square plus 1. So let's identify. So we have a is 2, b is 1/3, h is 1, and k is 1. So now we're going to say, what is our parent function? So you have to know what the parent function is. The parent function is going to be a square root. F of x equals x squared. So let's make a table. Okay, so if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, y is 1. If x is 2, y is 4. If x is negative 2, y is 4. So you see where, make sure you understand where I'm putting these values in. I'm putting them in to the parent function. So that's really important to know, because if you put it in the wrong place, and I get confused real easily. My brain is kind of scattered, so I have to be really careful that I stay organized. Okay, so let's put our formula chart into. So remember, A and K affect Y, B and H affect X. So we're going to start with our X. So we have B. So remember, the formula was what? 1 over bx plus h. So we're going to say, what's 1? This is b. So we're saying 1 over 1/3, or the reciprocal, which equals to 3. So we're going to say 3 times x, what is h, plus 1. We've already made this opposite, so don't make the mistake of making this to its opposite as well. Then we have a and k. Remember, a is times y. So what is y? A is 2. So we're going to do 2y plus 1. So now I'm going to take all these values in pairs, make sure they stick together, and put them in these formulas. So you're going to put 0 here. So 0 times 3 is 0 plus 1 is 1. 0 times 2 is 0 plus 1 is 1. 1 times 3 is 3 plus 1 is 4. 1 times 2 is 2 plus 1 is 3. Negative 1 times 3 is negative 3 plus 1 is negative 2. 1 again is 3. And if we put 2 in here, at 6, that's 7. 8, that's 9. This is negative 6. That's negative 5. And 8 plus 1 is 9. So now we're going to go and we're going to graph. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I don't know what I did. But, oops, whoops, whoops. Oops. Okay, I'm not even going to try and move this, because obviously I don't know what I'm doing. Okay. Sorry, guys. All right, so we're going to plot these. Whoopsie. Okay, so we're going to plot 1, 1. Let's do a different color. 1, 1, 4, 3, negative 2, 3, 7, 9, negative 5, 9. And our graph is graph with the, well, obviously it's not perfect because it's not graph paper, but you are going to do these on graph paper, and you're going to label these points and make sure, and then so we have the perfect width of our dilation. So if you notice, we have both a vertical and a horizontal dilation. So I want you to stop the video. On the where it says guided practice, I gave you 3 different ones, and I gave you a chart for the parent family. So if you have, so you're going to start with your parent function x squared, f of x. And I have values, but change those values to 0, 1, negative 1, 2, and negative 2. Put those in here for your y. Then you're going to use your formula chart and make the transformations to x and y, and take these and translate them, and then this is what you're going to graph. Okay, so you have 3 problems, and we will discuss this in class. I know it's a little confusing, but we will do more in class tomorrow. That's what the worksheet's for.